Okay, so I wanted to go over the second part of Chapter 9, 9.2, which deals with the linear regression, right? Basically, that estimates a line that summarizes these data points. And I'm picking this question number 9 because there's a question like that on the final. So I want to recommend that you do this problem and a few others in the homework, and make sure you know how to do them so that you can get it right on the final. Okay, so I'm going to step you through this. All right, so we have data points that relate the number of calories content and the sodium content in hot dogs. Okay, so are these two variables related? And one thing, there's another question on the final that has to do with labeling the variables. So why do you do regression? You do it because you want to be able to predict these values here. You want to let one variable predict the value of another variable. All right, so in this case, we're going to let X, the calories, predict the amount of sodium. All right, now, very important, that variable is called the explanatory variable. All right, it's in the Y, the result, the variable you're going to predict is called the response variable. All right, the X variable explains the changes in the Y variable, which is the response. All right, causes a response. If you change X, then it will cause a change in the Y. All right, so make sure you know that terminology because that's also on the final. All right, let's do this problem. We're going to come up with the regression equation. So as you know, you open StatCrunch with that little button there. And we're going to take these values and put them in StatCrunch using this regression simple linear. All right. Okay, the X value is the calories. The Y value is the sodium. Okay. And the only thing else you need to do is put in your prediction values. All right. So I'm going to put these in right here. 160, and then put a comma. 100, 120, and 50. All right, so what we're going to do is come up with the equation of a line, and then we're going to use that equation to predict these values, all right, to predict what happens when I have this number of calories. What does that do to the sodium? All right, so let's compute this. All right, so here's the results. All right, and the first thing I have to know is the regression equation. And to get that, you take these two numbers here, all right, the intercept and the slope. The slope is always next to the X, and then the intercept is the number by itself. And actually, this is the equation of the line here they're asking for. So let's put those in. So the one next to the X is the slope, so this one. All right, 3 decimal places. That's going to change the 3 to a 4. All right, and what happened to my, let's see if all right, and then the intercept is the 28.542. Okay. All right, so that's the equation of our line, and we have to find the graph of it. So first of all, we know the slope is positive, so it's going to be this one, but not those two. So it's going to be one of these two. And fortunately, StatCrunch, if you hit this arrow here, it draws the graph. All right, so it looks like it's a little hard to tell. It looks like this one actually. Yeah, so that's it there. And you can actually make your graph completely identical to that one by using these 3 lines. you would take the x-axis and make it go from 0 to 200. All right, and then the y-axis goes from 0 to 560. 0 to 560. And that's the identical graph there. You don't need to do that. If you get confused on which graph it is, that might help you. But we determined it was this graph. All right, and now predict the value of y when x is 160. All right, so basically the line of best fit, the linear regression line, will let you pick the value of the sodium for any value of the calories. All right, so obviously I only have about 5 or 6 data points here, but if I want to know, these values like 160, I don't have a data point 160, but if I did, how much sodium would there be? All right, and so if we look at our results here, all right, the 160 is 443, which is this one. Now, one thing that's really important, one of the answers here is not meaningful. You have to be careful when you predict values that your data point falls within the range of your original data set. All right, so this is my data set here. I can only use this line for data points that are between this point and this point. Down here, we don't really know what the behavior's like. Okay, but between these 2 points, we have this line to help us estimate. Okay, so 160 is between 80 and 180. So anything between 80 and 180 is valid. All right, let's see what here. X equal 100. That was 287. All right. Next one is 120. 120 is between our limits. So 120 is 339. All right, now this one says predict the y value for x equal 50. Right, if we have 50 calories, that falls outside the range of my data. So I cannot make a valid prediction with that, and that's when I pick not meaningful. Okay, so anyway, just to summarize, we're doing linear regression. So we want to find the equation of a line that best fits our data. And we use that line to make predictions for data points that we don't have. Okay, that's the idea. Make sure you know how to do this problem. I think there's another one, question 7 maybe. Make sure you know how to do that. And you should do fine on the questions for Chapter 9 on the final. I'm sorry we had to cut your last weekend short because of the outage, but hopefully with the adjustments that I'll make here, you're gonna do great. All right, let me know if you have questions. Thanks.